So, firstly, I'd like to introduce about the what I am doing in this term project. So basically, as we know, movies are the basic form of entertainment, and if taken as an entity, it has attributes like title, duration, release date, budget, and genre. And for this work, I have taken a big movie database, and I want to analyze this database for getting useful information like what kind of movies are getting good ratings over a period of time and what movies are getting a significant rise in ratings. So coming to the problem definition, I'm mainly dealing with this database so that I can get some application for the multiplexes and other screens or theaters so that they can analyze or predict the audience turnout rate for a particular movie in a particular time period for a particular genre. So for an entertainment company to get the maximum profit, they have to have a basic idea about the movie information or when to release, and if it's a big movie then that's no problem, but for a movie it had to take into consideration that a holiday season and another factors. And coming to the main problem, so my main issue here, I'm dealing with the movie database and analyzing the data so that to get to the useful information, like as I discussed earlier, like what kind of movies are getting good ratings over a period of time and what are the results I can get from it. So coming to the data set, there are many more data sets I can get, but presently, like there's IMDb, Rotten Tomatoes, and some review sites like Rotten Tomatoes, etc., etc. Like in IMDb, we have a similar pattern where we get the movie ratings and the votes for it. So for this term project, basically I have chosen a movie data set from GitHub, which consists of data related to around 6,000 movies released from the year 1900 to 2010 under the genres like action, animation, comedy, drama, documentary, and romance. And further going into the project I have created, as I have submitted the source code before, I have done the code in R programming with the help of RStudio. So basically these are the some of the files I created just to for the sake of a demo. I'm just now these are these are the main three files I have created, and this is a analyze report, analyze result where we can, this is just a sample of the data result I have created, and I have three more codes with me so that I can get other results. So basically coming to the data part, first of all I did the data pre-processing, which is nothing but I have made the quality good for the data, like the outside data mostly contains maybe incomplete, maybe noisy, and maybe inconsistent. Quality decisions must be based on the quality only, so the data has to be pre-processed before compulsorily. So the major tasks I have done in this code are: first is data collection. First, the data is collected from the GitHub website. As I have mentioned here, this is the website I got it from, and first I have taken the website here, and I have created a file movie underscore data in my system, and I have changed the column as this one as ref number, and I have created the file with the help of this command, which we can see is a Excel file under the format of CSV. So basically first I run this file, so you get is, so basically coming to the folder, what I have is here I have then this. So this is the file I have created. Just a second. So this is the file. So I have loaded the file here, and then getting to the next step for this Veka where I do the data mining part. Coming to RStudio and coming to data direction, I have taken the first and fourth column and removed them. So just so here we have found the minimum, maximum, median, first quartile, third quartile, mean, which helps in deriving the data set and further implementation of the results very easily. And coming to the third part, it is data discretization. In this data, the data we have got from the reduced attributes, we then apply some mathematical functions so as to get the movie in a particular decade it was released. It creates a text file mydata.txt in which movies are related to decades in which they are released. So as I'm running it, you can see this is just a sample data where this is the movie number, like it's a primary key kind of thing. It is related to the decade in which is released, and from the file you can see this is the mydata.txt. This is the primary key for the movie and it is the decade in which it is released. So coming to the main part here, it is box plot where I have used the basic graphical functions in the R programming to produce a box plot based on the ratings and the genres of the movie. The box plot represents the distribution of ratings of various genre, and the boxes, let me just run this. So as I have run, I have created the file and it is stored under the file name boxplot.jpg in the same folder I have been looking through. So going to the folder, and this is the box plot, and as you can see these dots are the actual data points and these boxes represent the 5 measures of spread where we use mean, median, maximum, minimum, first quartile, third quartile, so as to represent the boxes, and this is the basic graph representing the distribution of ratings of a various genre. And similarly, I can show you the other results I have found, like just a second. This is this here represents the frequency of movies as per their genres, and similarly this is the represents the evaluation, and the other graph, let me show you the other graph. This represents the evolution of animation movies by decades. So this is the analysis part I have done so far. So we got three graphs representing the what are the, first is the distribution of ratings of various genre, and second is the frequency of movies as per the genres, and the third evolution of animation movies by decades. Similarly, we can further produce many other graphs so that we can get useful information for it, like very useful. And later I have used this data in Veka. Veka is a easy suite which has collection of various algorithms, machine learning algorithms for data mining tasks. And for this task I have used this data set, and I have taken the nominal values of the here, and I have got the result various association rules regarding this. And basically it says that it showed that the ratings are directly related to the genre of movies, and here we basically omit for brevity. Over a span of time, the ratings become increasing for animation as it's consistently clear from the graphs and other determining association rules. Whereas the action movies stayed constant and the romance comedy movies decrease as compared to the previous years.